Before I start inviting our presenters for the pitch session, I would like to give a few words about the purpose of this session and why we came up with this format. What is the idea behind? So we have, in all research projects, we have a common problem, not only this one, which is a gap between research push and market pull. So we have quite frequently we have researchers that have their research, they work on this research for many years, but the market and especially end users are not able to grasp the use of this research push and how to implement this in short term. On the other hand, we have end users that are eager to have results in 1 year or even shorter, and they have their needs which are always urgent, and there is a gap how to translate, how to link these research ideas, concepts into marketable product. So we invited, for this session, we invited these researchers that have a concept or what we call low TRL level. TRL is technology readiness level. So typically TRL 1 to 3 is conceptual or maybe tested in a lab in a research institute. And then we go, in some cases, we will have here also presentation from early prototypes. The idea is to present it in very fast format. They have 5 minutes, each speaker has 5 minutes, and they have to explain what is the problem, what is the main benefit of their research, and the prize, if they, after this 10 presentation, there will be a jury, special jury, Jürgen, who is our research coordinator, who is sitting there in the back, Gabi, and a few other people, and there will be a special award. This is not the seed funding for a startup, unfortunately. In the ideal world, there would be money maybe to give them to start with the business, with deep tech startup or whatever. There will be, I think, Ivana is preparing some award, but there will be definitely at the end of this day, there will be award. Unfortunately, I will not be there, but Gabi, I will have to catch the plane. Gabi will give award to the winner. So without further delay, I will give floor to the first presenter, Bernardo Santos, from Oslo Metropolitan University.
Thank you so much. How do I control the presentation with this?
Yes.
Okay. Just to make sure, perfect. So morning everyone, thanks so much for being here, and for those assisting us online. I'm going to discuss one of the many outcomes that we had on Task 2.1, the telco pilot, which is threat modeling for 5G networks. This was a joint effort between Telenor, Oslomet, and Ericsson. So with the 5G mobile networks, we know that we have enhanced mobile broadband, and we have also massive machine type communication with the inclusion of IoT devices, which will lead to adoption of new services and the applications. And the thing is, something that we need to consider is that in 5G networks, they can be subject to not only some of the threats that we can see on a normal enterprise network, but we are actually subject to other types of threats because exactly of this massive connection coming from IoT devices. So it's something that we need to now consider more deeply. If we also think about what an attacker can do in a 5G network, we can also realize that they will have different behaviors, then will use different tactics and techniques. Something that we have to be aware, because with current MITRE attack frameworks, we cannot fully document or model an attack on a 5G network. So, with that in mind, we came up with our mobile framework, CONCORDIA Mobile Threat Modeling Framework. It's telco specific, and it's based on state-of-the-art MITRE attack frameworks. It's basically a combination of enterprise, mobile, and others, but also, and most importantly, with already CONCORDIA own techniques. So we also provide some input as well. Luckily, and thanks to an extra push coming from Siemens and Circle back in Luxembourg, we had this deploy on MISP almost a year ago. If you think about it, it's already quite an achievement. And we managed to publish this recently in a quite respectable mobile communications conference. So we were very happy about that. So simply put, what does this does? If you think about it, it still has the same premises as the MITRE attack frameworks, but we still use tactics and techniques, the same methodology. However, we consider differently because no tactic is unique with our framework. We consider it as a phase. That is an important part. Also, we need to consider that attacks can occur on multiple devices, so we consider recursive, and we represent by that using loops. You can see that. So it's not just one device that matters, it's actually the combination of multiple devices that can then deploy an attack. Also, and an interesting aspect coming from our framework is that not only you can see the impact of an attack on the device side, but you can also see what's going to happen simultaneously on the operator's network infrastructure. So we want to give a more broader and complete overview of the impact of this attack. By the way, this example that we have here, and I'm happy to discuss this after the presentation, this is regarding flood attack on mobile networks. This is probably one of the biggest threats to come because of the IoT devices, and this is something that still requires a little bit more study. Simply, and future plans, this is still ongoing and we hope to still grow. We want to add more techniques or tactics regarding the possible threats that will come. And we also want to adapt eventually and see if some of them have become deprecated. Also an important aspect, and I think we also, as researchers, need to consider this aspect, is that recently the MITRE Foundation actually came with their own proposition for 5G networks called MITRE Fight. So this basically validates that telcos and mobile needed this type of modeling, and they now actually came with their version. And we hope that we can perhaps provide some contributions, some inputs to them, and we can combine our efforts together. So that was it. Thank you so much. If you have any questions, and we can just address it offline too. So yeah, thank you.
Thank you very much, Bernardo. I forgot to mention that all posters are, of course, there, and all questions for individual presenters can be made there during the break. So we will have, at the end, we will have question and answer session also for general questions about this session. The next one is Amr Alanvar Abdel Hafez from Jacobs University, and it's about logical zonotype. 5 minutes.
Good morning, everyone. It's my pleasure to present our work, Logical Zonotype, a set representation for breaking ciphers in a linear time. I hope you are awake and you are ready for this short talk. So let's give a lot of information. So we consider an ethical hacking problem in which we have a message, and the encrypted message, it's cipher, and we aim to find the key. So we have here our friends Bob and Alice, and they are communicating over a secure channel, and we aim to find the key that's used in the message and the cipher. And to have a key and look for a key, we need a complexity of O of 2 to the power n, which is the number of possibility for the key. However, through logical zonotype, we aim to decrease this complexity to O of n only. So let's see how we do it. So logical zonotype consists, we propose this set representation, and we came up with this idea of introducing sets in the binary domain, where the logical zonotype consists of a center and some logical and some binary vectors called generators multiplied by beta, where beta takes all the combinations of zeros and one. You can look at the beta as turning on and off the logical zone, the generator. For example, let's take a quick example. Yes. we have a center here, and we turn on the first generator to represent the second point, and then we turn on the second generator to have the third point, and then we have 4 points represented using 2 generators. So the idea of logical zonotope that we can represent 2 to the power n points using only n generator. Let's take a quick example for that. So if you have a center and generator, you can represent with beta equal 0 here, and beta equal 1 here, 2 vectors. So with 1 generator, we have represented 2 vectors. And then using 2 generators with all the combinations of zeros and ones, we can represent 4 points as we will see now. So first was beta 0, 0. So we XOR the center and the 2 generators. And then 0, 1. And then 1, 0. And then 1, 1. And the powerful point about logical zonotope that we will do the operation over the generators, not over the points. So instead of iterating over the points, if you have 2 sets and you would like to do the XOR between all the points in the 2 sets, you can just take each point and iterate. Instead, we propose the following. We have proved that you can do just XOR between the center and concatenate the generators. So we are working over the generator space and reducing the complexity of the operation by working over the generators. And then we tried a very simple cipher for now, which is used intensively in stream ciphers. So we start by a set of keys, and we are looking for the key that matches the message to the cipher. And the idea that we start by a set of keys and then do some set operation and check if the given cipher is inside the cipher set. If it's inside, the starting key set was correct. If it's not inside, we can just neglect set of keys. By doing this, we decrease the execution time from 10 to the power 6 to 2 seconds for key size of 30 bits, and for 120 bit from 10 to the power 33, 33 to 8 seconds only. So the takeaway message that we have represented logical zonotope and we have decreased the complexity of exhaustive search. Thank you so much.
Thank you very much for keeping time, 5 minutes. We have the next presenter from Ericsson, Kim Seong-hyun, and she will present defense against membership inference attack to 5G IoT systems. Kim? Oh, sorry.
Hi, my name is Kim, and from Ericsson Research Security, and this work is about the machine learning, the threat on and we also talk about like how the defense would be like against such a threat. And this work is also from the collaboration of like the RISE, Swedish Institutes of Sweden. RISE and the Ericsson as well. And here. So during the last 10 years, so machine learning has been reshaped the software industry like a lot, including 5G. And that's the one example that like how the technology has reshaped. So you can see that like on the left side, there is the data and the 5G function that's to use those data and that is get trained, and it became like a machine learning model, and it eventually going to be provided to the users or like the other modules. So one very interesting aspect is that machine learning has reshaped the software. Like now it's like a data model and exposed API to connect each other. So it's the one interesting aspect of how machine learning has reshaped. So the thing is, the machine learning technology is also impact the attackers, which means attacker use the machine learning to attack machine learning. So if you see the on the right, so you can see the adversary that's tried to replicate the training data. One interesting aspect is that they try to replicate the training data because they don't have to come and get and copy and paste the data. They just artificially generate queries and they send queries and try to gradually extract information about the training data set much as possible. And that data set could be a sensitive information, or it could be privacy information as well. So in that aspect, it's a threat. So then so what would be the defense techniques against that? Because especially privacy and the intellectual property rights aspect, it's quite serious. So the one defense techniques regarding the defense against such a threat could be differential privacy algorithm and the model regularization algorithm and the adversarial training. So our work, basically we tried more or less everything in this technique, and we evaluate and how much they are effective against such a threat like membership inference. So we can't really talk much about each one of them, but we can talk more about our poster section, and here's our future plan. So one interesting way would be model interpretability, and because the interpretability of the model could be really interesting feature when it comes to a defense algorithm against the machine learning the threat. So that could be one indicator for us to defend against such a threat. And another one is there are multiple threat, because one threat that we have checked is the membership influence attack, while there are multiple other threats exist. But we haven't really tested about the defense algorithm against that. So attributing the candidate would be attribute influence and the model inversion attacks at the same time. So thank you. It's the end of the talk, and I would love to see you in the poster section. Thank you. Bye.
Thank you. Thank you. Thank you very much. And it is really amazing that everybody stick to the 5 minutes time. We have a next presentation from Kitty Kioskli from University of Essex, and it is about privacy by design approach to model supply chain of a living lab.
Thank you. What about the...
Here.
Is it the red one? Okay, thank you. Hello, everyone. I'm Dr. Kitty Kioskli. I'm from the University of Essex and Trastilio BV, and today I'm going to briefly talk about privacy by design approach we adopted as part of the Horizon 2020 project AI for HealthSec in order to identify the supply chain of a living lab. So healthcare organizations are daily attacked by malicious hackers who aim to expose the security strategies and vulnerabilities of the assets. The living labs are part of the healthcare ecosystem in which innovative methodologies and tools are developed and validated. However, there is a lack of research regarding security and privacy issues within the living labs. So the overarching aim of our work was to identify the detailed supply chain of the stakeholders of a living lab and further recognize security and privacy issues alongside with associated vulnerabilities. The methodology and analysis that we used for this research was by the privacy by design tool Secure Tropos. So, as we well know, when we talk about supply chain, we mean a web of interconnected assets, processes, and stakeholders used to provide a service. The detailed supply chain of a living lab here is the citizens, public actors, private actors, knowledge institutions, and healthcare professionals. The supply chain is interconnected and ensuring that data and inputs come from participating supply chain stakeholders. They become part of the information technology infrastructures, however they come with emerging threats and risks coming from using and testing this kind of technologies. So we are proposing a set of awareness mitigation strategies for the living labs for the security and privacy issues that they face. Firstly, to keep a balance between the technical and non-technical knowledge. Secondly, organize formal and informal meetings between all the involved stakeholders to manage the level of knowledge, their needs and their expectations. Arrange, of course, practical and interactive cybersecurity trainings. Keep them informed about the ethical implications, the policies and the standards that they exist. We very much want to stress out that it's very important to involve behavioral and social scientists as well as psychologists when developing security standards in order to make sure that psychosocial, behavioral and human aspects are considered when developing security standards. So by this, with this supply chain holistic modeling, we wish to instigate the development and application of mitigation strategies, and also to help professional bodies and organizations to avoid wrongful practices, increase awareness and communicate their needs. That would be all from me. Thank you very much for listening.
Thank you very much. This was, again, perfect timing. We have next number 5, Han Wang from RISE Institute with presentation Robust and Communication Efficient Peer-to-Peer Federated Learning.
Hi, good morning, everyone. My name is Han Wang. I'm from RISE Research Institute of Sweden, and I'm really happy to introduce this work that's collaborated with Imperial College London. This work is called about robust and communication efficiency, peer-to-peer federated learning. So I would like to first introduce some brief description of federated learning. I think most of them you know. We have, in federated learning setup, we have the center cloud and we have several clients. And each client, they have their own local model and they train locally. And when the the center cloud, when they call for aggregation, the clients will send back the models update to the global cloud and you will set up another round of training. It's like a federated learning setup. But at the same time, there are so many challenges we need to solve. For example, the expense communication is, you can imagine that because you have to communicate with a global center cloud, you need to upload your models and you need to download the models. So it's uploading and downloading is cost a lot of communication overhead. And also because in IoT network, like the system there are various different systems. So it causes system heterogeneity and it also makes the data system heterogeneous. So which means the data will be in non-independent and identically distributed, which we said non-ID distribution. And we will also have some imbalanced data set. And at the same time, there are some adversarial attacks which we can target in the federated learning models. So it's vulnerable to regular adversarial attacks such as poisoning attack. So in this work, we propose a new framework that we propose to have the peer-to-peer federated learning, which means there's no center cloud to coordinate all this training process. We are just say the clients talk to each other by themselves. So for example, you can see a network topology here, like this more like in a wireless sensor network, like each client just communicate with their peers. They are connected. And of course, we also provide the new technology that we can reduce the communication overhead. And we propose the robust aggregation rules that can identify the adversary or isolate them from the model aggregation. So, and we also will survey that when we see where the adversary locate, maybe it's in here or there, and how it connected can affect all the training process. And here I want to briefly to talk about some state-of-the-art methods. For communication efficiency, they have some methods like they use model specification. They only share some of the parameters, but not all the model updates. And also you can use quantization techniques, and also you can try to reduce some communication frequency, and you can also do some parallelization. All of this can be done to improve the communication efficiency. And there are some defense techniques to defense against adversarial attacks, poisoning attacks, such as you can compute the similarity between different models updates, and also you can try some statistical pruning to prune some weird parameters. So this work is, we are on the review, so we cannot say much in details, but if you are happy to come back to my poster, I can discuss with you. But then for the future plan, we are actually try to investigate more target or activity to the federated learning setup. And also we would like to survey more on random network topology. And also we aim to concern some privacy attack as well within federal learning setup. Yeah. So thank you very much. Yeah, that's all.
Thank you. Perfect. We have next presentation from Pantelitsa Leonidou from Cyprus University of Technology, Privacy Preserving Online Content Moderation.
I will present.
Ah, you're okay.
Hello, everyone. I'm Nikos Alamanos. I'm a postdoctoral researcher from the Cyprus University of Technology. And I will present you a collaborative research work with Telefonica Research. It's about the applications of federated learning in building online content moderation tools with a privacy-preserving property. Regarding our motivation, the online content moderation tools have as objective to flag or take down harmful content on social media, where the harmful content may expresses abusive behavior, racism, hate speech, and other types of misbehavior. In order to build content moderation tools, generally the main approach is to to train classifiers, to apply machine learning techniques and train classifiers in large data. Okay, but this data, if we do that in a centralized fashion, this data is users' data. So there is questionable if this centralized process can comply with the EU privacy policies regarding the user protection. In order to address this issue, propose a differentially private federated learning framework. And this is a work in progress, and our final vision is quite ambitious. We want to achieve, to guarantee user privacy, high classification performance, and at the same time, low overhead on user devices. In our proposed framework, our proposed approach, the PROM, there are three main actors. We have the client, which we assume that has stored some local data, labeled data, and also will train locally the classifier in federated learning fashion, over here. We have the server, maybe is the platform, the online platform itself, or a third-party entity who consider the server as a trusted entity. Also, the server is responsible to coordinate the FL tasks, collects the updates from the clients, aggregates the model updates, defines the next global model. And there is also a third entity, a potential attacker, who may perform membership inference attacks on the users that are the client and the users' data that are participating in the training phase. As a defense, we apply central differential privacy. We apply DP noise in the training phase locally and on the server side. That is why we need to have as an assumption that the server is a trusted entity. Regarding the evaluation, we conducted simulations of the differential privacy model, where we have the main parameter is the privacy cost, the epsilon, actually. We perform simulation. We have three control parameters: the percentage of harmful tweets in local data sets. This is actually the classes ratio, because we deal with binary classification. We have also the client size in terms of data points, and the number of clients that are available for FL training. Also, we evaluate our proposed approach in 5 Twitter datasets with different types of harmful content. And also, we quantify the overhead on user devices. One of the main results is that the private central DPFL is here. In short, we can have medium privacy, and the model, the private model, can achieve a classification performance quite close to the non-private one, and also is not that far from the centralized approach when we have the training in the classical ML fashion. So that means that applying DP noise in the training phase will not alter the classification, will not affect that much the classification performance. But this, we can achieve that for medium privacy. Yes, I know, I'm sorry. As a future one, we want to try mainly with non-IID data, other client selection mechanisms, and maybe we're going to use auto-labeling in order to overcome the problem that the client may not contain labeled data. Okay, thank you very much.
Thank you, Nikos. We have the next presentation from Konstantin Scharschmidt from SMT Berlin. Yeah, Konstantin. Ah, okay, sorry. Sorry, so we have, yeah, maybe you can present yourself also, because I have here Konstantin, but these two persons.
Because he was the contact person. It's okay. Thank you very much. Good morning, everyone. My name is Duk Anle. My colleague Konstantin Scharschmidt and I are grateful to be able to present the legal aspect of this great topic, cybersecurity. And our focus today would be the legal framework in Germany. The root of our project is from the systematization project of IT security law in Germany, where we're trying to bring all the security regulations in Germany together and try to systemize it into a more coherent, logical, and transparent norm system. However, today we would like to bring the focus of this to the so-called hacker paragraph, the 202A of the criminal law in Germany, because the current problem of this norm is that it includes ethical hacking as well in the prosecution process. With the current rise of zero trust vulnerabilities, we believe that cybersecurity researchers are now even playing a more important role to achieve cybersecurity, and we would like to support them and help them by creating a legal certainty for their work. We currently have developed 4 possible solutions. One of them, or the first 3 of them, however, do not ensure this legal certainty that we wish to achieve. The first one is to rely on the court's decision that they are going to see cybersecurity research work as a justified defense mechanism. However, this is case dependent in each case, which is why it will not create like a precedence such as in common law countries. The second solution is that to rely on the internal instructions by the Ministry of Justice. This is something that recently the US government has also decided to do, to exclude cybersecurity researchers from the prosecution process. This, however, stays as the same problem, which is to achieve legal certainty. And last but not least, also the third solution, which is to remove completely this norm. However, I think that criminal hacking should still be sanctioned and prosecuted, so I will not suggest this will be the optimal idea, which is why we see our fourth solution as the most promising one, is to regulate a coordinated vulnerability disclosure procedure to legalize it in a manner so that cybersecurity researchers will get the attention that they deserve for ensuring cybersecurity. During the research of our last solution, we discovered 4 advantages that needs to be considered. One of them is ensuring clarity and legal certainty, as we already mentioned. The second advantage is to maintaining the prosecution of hackers. Not just that, we might be even go a step beyond, for example, hacking into critical infrastructure. I think that one might even raise the sanction level in these cases. And the third advantage is to achieve acknowledging the researchers' workers. So with regulating such a vulnerability disclosure procedure, I think this will even raise more attention to every business people, every government, and so on, to appreciate more the cybersecurity research works and maybe even to reward them, such as promoting bug bounty programs. And last but not least, to be coherent with the upcoming EU directives, which is the NIS2 directive and the Cyber Resilience Act. What are our upcoming challenges in this project? First of all, we would like to analyze and keep comparing these 4 solutions, but on different levels, on the national level in Germany, on the EU level, and on the international level as well. This should also lead to the next phase, is to do an empirical research on how the current cybersecurity research works as in the status quo. And our second upcoming challenge is how to implement all these ideas in the upcoming NIS directive and the Cyber Resilience Act. And last but not least, to raise an international coordination and to raise media coverage, which means that we would like to send a beacon to every nation that we should legalize cybersecurity work in a strong legal framework so that everybody in the research department can work safely. And we would also want to go one step further by making sure that we have a more effective regulation for innovative ideas and for startup as well, which was also mentioned yesterday in the panel. I would like to thank you for your attention. Like Judy Gerlach said yesterday, she wants to promote cybersecurity in every generation, to children to learn programming, maybe to learn hacking as well. And I believe that we would like to contribute it by developing a legal safety net so that she can, and so that everybody can do these research works as well. Thank you for your attention and have a wonderful day.
Thanks to you for keeping your time. If you're wondering why I go here and there, it's because I have to do my morning exercise, and I did already quite a lot of steps. We have number 8, a presentation from Filippo Berto from University of Milano. And the presentation is about an assurance specialized network function for the 5G core network.
Thank you very much. Hello, my name is Filippo Berto, and I'm here to present my recent project on 5G networks, in particular an assurance specialized network function for the 5G core network. So the core network of 5G is a composition of services that provide network functionalities. And each network function is a singular service that follows a strictly regulated API. And every service has minimal responsibility, and the edge network function provides monitoring capabilities, so we can have information about what the singular service is doing. The problem with the current implementation of the API is strictly related to the performance of these services, as in the throughput of the network, the latency, the time of response of these services, and the number of connections for the singular cell. But this is not enough for the future generation of services that are deployed on the 5G network. The 5G network becomes a platform for deploying services that are very geographically close to the clients, to the users. We need something more. We need a better API that gives us more information about the platform that we are using. For example, we may need information about hardware acceleration capabilities of the host, or the profile of other services that are running in the same node, or even like the energy efficiency of the node. This kind of information is very useful if you want to choose where is the best place to deploy your services in a very distributed fashion. So our objectives are the following. We want to implement a new network function, a new service that is focused on assurance. In this way, this service will collect information from metrics from other services that are running in the same node, and expose an API that allows us to query this information and get in-depth information on what is happening inside the network node, inside all the services in the host. We want to formalize a framework that allows to define properties of the services, of the host, and all the deployment that is running on a node. And we want to implement a continuous certification service that allows to verify if the properties are met for each of the services that we are running. So the expected results of this research project are the formalization of service level properties, the implementation and integration of the assurance network function inside the core network, and this will be implemented in a testbed network inside our lab. And finally, the introduction of a standard API that allows us to describe properties for the 5G network and to verifying them through the network, through the assurance network function. So, thank you. And if you have any question, please, I will be close to the panels.
Thank you. Thank you very much. Now we have presentation which is in remote. This is the only presentation which is done through online connection. This is from CyberDetect. I'm not sure who is online, Sylvain or...
Yes.
Yes, okay, Sylvain is a packet malware detection with morphological analysis. You should, I will turn the slides, or you're turning, I'm not sure how it's working. I will stay here just in case.
I can do it, I guess.
Okay, okay.
Thank you. So hello everyone, I'm Sylvain Sechetto from CyberDetect, and I will try to explain you how we do to detect packed malware. Okay, so as you know, the field of malware detection is vast, but we can consider two main techniques. Similarity analysis, that is the field of well-known antiviruses that are using signature detection engines, and the field of behavior analysis, that is watching abnormal behaviors. Our method is focused on the first field, which is similarity analysis. This analysis has two main challenges. It is weak against malware evolution, as you can see in this virus total example, showing the detection rate of a new malware sample over the days. At an early stage of a new version of a malware, these signatures have issues. And it is also weak against obfuscated files, since it will, in general, analyze files statically. There are many obfuscation methods. The most frequent method is packing algorithm that will start with an encryption step first and a classic execution step at the end. If we have a look on a binary file that is packed, we will see an encryption function and some not understandable data. Armless software also use packers for many things, and it is difficult to decide what to do in this case. Our method is based on an engine that analyzes binary files represented as a graph of instructions. From this instruction, we can compute a standard signature more or less automatically. But we do not stop here. We make specific transformation on this graph to make it in a form that is strongly resistant to code modification. And we shutter this graph into different parts that we can see like different functionalities of the binary. And these functionalities will be of detection factor. We call this method the morphological analysis. This approach means that a malware author will not be able to easily modify its malware code to keep the same functionality on one side and manage to be undetected on the other side. Our method allows us, considering many harmless files and malicious ones, to generate our databases automatically. And these databases are composed of a set of hashes and are very light and easily upgradable. This engine was first developed to detect malicious functionality, but with so many packed files in the wild, we can use it in different ways. The same method can be used to detect packing procedures, and not only packing procedure, but we can also distinguish usual packing procedures that can be used in either harmless or malicious files than other packing procedures that are used specifically in malicious files. It is interesting to have a look on the full workflow of the tool. With the morphological engine specialized in packer detection and classification, we can apply specific procedures based on the analyzed file. We first check if the file is packed or not. Then, thanks to the packer name that we found, we can try to unpack the file with a specific procedure. If the packer is unknown, we use our sandbox analysis tool in order to generate a trace execution. This trace contains all the instructions seen during the execution of the self-modifying files, wave after waves. Because the trace contains instruction, we can use it with our morphological analysis engine. And this engine is at the heart of each of these procedures in order to conclude at the end of the workflow if the payload is detected as a malware or not. This morphological engine is a true cutting-edge technology, and it can be applied in many domains. Binary executables are especially difficult to analyze, so we focused on that, but it can be used to analyze scripts or industrial components. And this similarity engine has also shown very good results to detect CVE that are embedded in third-party softwares because of static libraries that they used. Thank you for your attention.
Thank you. Thank you very much. We are coming to the end. The last presentation is from Nicolas Cortelis from Telefonica. It's Federated Learning as a Service. So, please.
Thank you, Alyosha. I guess we can use this. So, thank you, everyone. I guess after all these ML and FL kind of presentations we had, I may not need to talk too much about what is ML. Can you hear me? Yeah. So, in general, ML is used to solve a specific problem, usually on user data. These data are typically collected in a centralized location. However, we have a problem nowadays with respect to privacy. How do you collect this data and how do you analyze them? In the recent past, we have seen proposals from the industry that we call ML as a service, where companies that do not want to deal with the overhead of building a team and being experts in ML to analyze this data, they can use these third-party services. we have in Azure, we have in Amazon Web Services and so on. And it is a market that will grow in the next few years. Now FL, you have seen from other presentations as well, FL tries to kind of break this problem by training the model not in the server, but on the user devices or in a decentralized fashion. What is happening is that we do have some companies, such as big tech, Google, Apple, Microsoft, Facebook, etc. They build their own in-house solutions for their products. We do have some open source platforms or libraries that are trying to also disrupt the market, but all these solutions are not up for the task. And why? We still have unanswered questions. So how can a company, think always an SME, how can they train a machine learning model using these, let's say, MLAs, APIs and SLAs, but in a decentralized fashion? Sorry. How do they do that without worrying about privacy regulations, without building a whole team of FL and ML and privacy experts? How do they do that in different devices, different environments? How do they collaborate with other SMEs to train something jointly? And especially, how do you do that in the same platform? So we may have bits and pieces here and there in the ecosystem, in the market, but how do you do that under the same? So that's where we proposed FLAS. FLAS, FL as a service, basically is a framework, it's a middleware that allows such a company to train the model in different environments. It could be user devices or the edge. You can construct the model in a hierarchical fashion that already exists out there. You can use APIs that the FLAS offers you to train this model and also have SLAs and privacy and permission management and so on. And furthermore, it allows you to do collaboration across other companies. The target users, as I mentioned, are basically teams that do not want to bother with all this overhead, right? So instead of outsourcing that to a third-party MLAS, they could use this middleware as FLAS. Examples of such scenarios, think of the typical, what type of song should I recommend to my user, or what type of product to offer, or is my patient have cancer, a rare cancer or not. So we are envisioning these single kind of situations, or even if you have 2 or more laboratories or hospitals that want to collaborate and share models on their health records data, but not the actual data. Similarly, with bank transactions, we also have in Concordia the threat intelligence platform for finance. So we have these examples that can be use cases for FLAS. Current and future plans. So in case you got the chance to see the poster and the demo yesterday, we have a prototype working. We are looking into building some more technology. We have published this and patented it. In the future, what we would like to do is really work on a specific few use cases that can demonstrate the technology. And of course, advance the technology from the point of view of using asynchronous FL, addressing various types of attacks, such as model poisoning attacks, and also integrating with hierarchical network and multitask modeling. Ya está. Thanks.
Thank you. Thank you very much. So before we go for a coffee, as I said, we have time at least for one question. Generic question, you can ask specific questions during the break at the poster session. If there are generic questions about this session, about procedures, about the idea behind anything, please raise your hand. No? Then I do have one question for all participants that presented, all 10 persons that presented. Ideally, in this presentation, there will be one more slide, which is about what do you need? What do you need? What do you ask for? Do you ask for additional funding? Do you ask for users? You're looking here in community for users where you want to make proof of concept. Or do you need a specific data set? So ideally, if we had one more year of Concordia, there will be one more slide where you really coming here and knowing what are you looking for, and maybe we can have in a community user that is really looking for a problem, that has a problem or challenge that you are describing. Or it could be open call for proposals where you can apply and get additional funding to continue and mature your TRL. So this is just pilot project, and this is a pilot procedure on how to bring closer research and industry and the market. Thank you very much, everybody.
So, dear Concordians, ladies and gentlemen, may I ask you come again a little bit more in front? And we are now at the award ceremony. We had today in the morning 10 perfect, amazing speeches and saying what people are doing, what was their research, innovation, and so on. And so the board has come together to find a winner. And we had a hard discussion because everything was so good. And it took us, I would say, half an hour to discuss and to find who the winner would be. And it is my pleasure to say that, for example, federated machine learning, peer-to-peer, sounds like a promising approach. So, ladies and gentlemen, please applaud with me Hangwan for her terrific speech, and she is the winner of our ceremony. Please. So, congratulations. And of course, a picture. I hope pictures are taken. Yeah. So, and here's the official certificate of Concordia 2020 for the award, and of course a little bit some chocolate or something like that. Also for not just the brain, but also for a little bit for the stomach.
Thank you very much.
So a great applause. That's great. So, maybe the next time, next project, we would offer also in such case, to have speeches also in front of investors, so you can also get some money, seed funding, to get some money of it.